In this video, we will use the p-adic absolute value that we defined in a previous video to turn Q into a metric space. So we'll use the p-adic absolute value to make Q a metric space. And to define the metric, so we define a map from Q cross Q into the real numbers by the distance between X and Y is the p-adic absolute value of X minus Y. So this is basically the distance between X and Y on the real line, except using the p-adic absolute value instead of the ordinary absolute value. And we'll show that this makes Q into a metric space by showing that D is a metric. So we have to prove that D is a metric. Well, this actually pretty much follows from the properties of absolute value that we have seen. So first of all, the first property is that the distance between X and Y is greater than or equal to 0. Well, certainly that is true by definition of the p-adic absolute value. And we know that the distance between X and Y is 0 if and only if X is equal to Y. All right. The second one is the symmetric property of the metric. So the distance between Y and X, well, that's by definition the p-adic absolute value of Y minus X. And then if you factor out a -1, this is going to split up into the p-adic absolute value of -1 times the p-adic absolute value of X minus Y. The p-adic absolute value of -1 is 1, so this is just the p-adic absolute value of X minus Y, which is by definition the distance between X and Y. So the distance between Y and X equals the distance between X and Y. Then the remaining thing we need to prove is the triangle inequality. So let X, Y, and Z be rational numbers. Then the distance between X and Z. So we want to show that this is less than or equal to the distance from X to Y plus the distance from Y to Z. Well, by definition, that's the value of X minus Z. And then we can write this as this, right? We just stick in -y and plus Y. And then we know by the property of absolute value that we've seen before, this is less than or equal to the p-adic absolute value of X minus Y plus the p-adic absolute value of Y minus Z. And then this is the distance between X and Y plus the distance between Y and Z. So that proves the triangle inequality. And thus, Q together with this p-adic metric, p-adic distance function, is a metric space. So all the properties of convergence and stuff carry over to the setting. Moreover, the function D satisfies that the distance between X and Z. So we have that the distance between X and Z given Y is equal to this. And we actually have shown not only that it's less than or equal to the sum of the absolute value of X minus Y and Y minus Z, it's actually less than or equal to the maximum. So this shows that the distance between X and Z is less than or equal to the maximum of the distance between X and Y and the distance between Y and Z. So this inequality is sometimes called the ultrametric inequality.